We've seen that with the recognition of the synoptic situations, we can determine the wind prevailing over different sea areas. Now, what I'd like to begin together with you is to practice how to identify the wind prevailing over the areas where we are most interested. Let's consider this example of a synoptic situation showing a large vortex of low pressure centered over the Bay of Biscay. We can immediately notice it is associated with a system of fronts, a warm front crossing over Corsica and the Ligurian Sea, and a cold front following it and crossing the Iberian Peninsula. We have now to wonder what is going to be the prevailing wind over the Balearics. With an anti-clockwise rotation of the wind flow over the Balearics will be from the southwest. Therefore, it's properly a libiccio wind, becoming a south-southwesterly wind, even across the Ligurian Sea and to the west of Corsica. At the same time, as you can see, the whole eastern Mediterranean is under the influence of a large area of high pressure. The areas with wide-spaced isobars give way to very light winds, even to calm or eventually coastal breezes in the anticyclonic area. This is a snapshot of the actual weather used for educational purposes to highlight in a glimpse the situations we are interested in. In this way, the wind rotating anti-clockwise would be a libiccio on the western side, whereas the airflow is still westerly on the Adriatic side, but with a much weaker force. In this position, behind the very clearing front, you will find a wall of black, thundering clouds, with a trough clearly most typical of post-frontal skies, and this is why it alternates with clear periods still in the presence of isolated thunderstorms. It could be described as a cyclogenus, that is, a depression centered over the Ligurian Sea. It's a typical low studied by meteorologists all over Europe and elsewhere, as it is a situation usually occurring in this part of the Mediterranean. In this case, as we have an anticyclonic area present over the Alboran Sea and the Balearics, and as the wind rotates in a clockwise direction around the highs, the wind will burst into the Gulf of Lion from the northerly quadrants. That's what we call the Mistral. Over the Balearics, the wind is from the north, but much weaker, whilst a vortex of low pressure over the Gulf of Genoa would give quite a different character to the wind over Cape Corse, causing most likely an airflow from the southwest, taking La Spezia as a reference point, and southeast and northeast over the Cape Mele area. The westerly airflows are more moderate on the Adriatic side. All that is accompanied by a large frontal system, which is nothing else than the intrusion of cold air over a Mediterranean Sea, which was probably already heated by the sun in the previous days. Looking now at the nearest area of the Atlantic, we can notice that even this area is characterized by a low pressure center with a prevailing southwesterly airflow, as winds always rotate with this type of circulation. In this way, a vessel sailing from the English Channel toward Cape Finisterre would clearly meet headwinds, even sustained ones, as the isobars are very close one to the other. On the contrary, the airflow is minimal over the Aegean, with a dominance of coastal breezes. It is certainly not a kind of Meltemi wind situation. Let's see why. This is a typical Mistral situation. The high-pressure ridge, which is in the area where the Azores high spreads towards the Mediterranean and reinforces the pressure gradient, that is, the isobars getting closer. This means that we can expect a stronger wind. A strong wind blows away from the northerly quadrants, as the wind circulation is anti-clockwise even in this case. The Mistral over the Gulf of Lion will then spread, becoming westerly-southwesterly over the southern Tyrrhenian Sea. The warm front, followed by the cold front, is moving eastward. In a typical situation, the rotation of the cloud systems is accompanied by the prevailing winds. This other synoptic configuration is typical of a Sirocco wind. Looking at this pattern, we can easily spot a low pressure center over northern Africa, while the wind rotates anti-clockwise once again. It's clear that the prevailing airflows over the Tyrrhenian and the Adriatic come from the second quadrant, which means they are sirocco winds. Sirocco is a synonym of hot and moist air, which is associated with a warm front, bringing widespread precipitation and electrical activity. We're not talking about thunderstorms actually, but just rain distributed over the whole Mediterranean. In this satellite image, we can see a huge vortex of low pressure lying over the Mediterranean. Here you notice a cold front with a clearing after its transit. In this area, the winds keep changing direction over a short distance. This means that a vessel heading southward, coming from north, will face rather different marine weather conditions at the beginning of the crossing than on approaching the vortex. Over the Balearics, clearings frequently appear. This orographically induced Mediterranean depression develops quite frequently and causes problems to a great number of vessels coping with the western routes in the Mediterranean.